Good afternoon, good evening. Thank you for joining us in this very first tinyML Technical Forum Asia. My name is Wei Xiao. I'm from ARM Machine Learning Ecosystem. It's my huge pleasure to be on the technical program committee of tinyML Asia. So our second presenter today is Dr. Rajen Bhatt, who is the Director of Engineering from Machine Learning team of Qeexo.
Greetings everyone. Today I'm going to discuss Qeexo AutoML, an automated platform for sensors-based machine learning. It develops high-performing, low-latency and low-memory footprint machine learning models for tiny embedded targets as small as an ARM Cortex-M0. I am excited to share that it had been shortlisted as a CES 2021 Innovation Awards honoree. We will find out next month whether we win. Building sensor database machine learning models for embedded targets is challenging due to their memory and compute constraints. The overall process is also time-consuming and complex. Qeexo AutoML manages the entire workflow from sensors configuration to deploying and live testing of machine learning models on the target. That accelerates the overall process of building and deploying commercial-grade machine learning models at scale. Qeexo AutoML also has many unique features. It supports automatic sensors and feature selection, so users need not to have a deep domain knowledge of sensors and signal processing to extract relevant information. It handles streaming sensor data efficiently for featureization and classification and supports hyperparameter optimization. Live testing, classification analysis, and sensitivity analysis are also supported to help deploying models in the field. In addition to neural networks, it supports many other kinds of machine learning models which sometimes are more relevant for the embedded applications. This platform has been built by machine learning engineers for machine learning engineers and used by Qeexo for many years to deploy commercial-grade ML models which are running on more than 400 million smart devices worldwide. So let's take a look at how it works. We will build multi-class classification application of human activity tracking on ST Microelectronics WinKit. We will begin the process by doing the data collection, and for that purpose we will configure accelerometer and gyroscope sensors. We will configure their ODR and FSR values. Then Qeexo AutoML will automatically build the data collection library and flash it on the target. Once the library has been flashed on the target, we will connect with the target using Android companion app, and then we will begin the data collection. Here, we will first enter the class level idle and collect 50 seconds of data for this class level. You can see the collection progress here. And then similarly, we will also enter running and jumping classes and collect 50 seconds of data for both the classes. The data is being recorded in the CSV format and stays on the device. After the data recording is done, we will transfer the CSV file to the computer and begin the training of machine learning models. Here we are uploading the CSV file. AutoML will parse the sensor configuration. The data will be uploaded, and then all the data will be visible on the datasets page. We select the data from here and then start training of the ML models. Skip the grouping for now. We will select automatic sensor and feature groups and then would enter the inference settings. After that, we will select the machine learning algorithms. We will develop GBM, random forest and XGBoost models and start the training. AutoML will show the live training progress and at the end of the training, show the training results. We can see here GBM model has the highest performance and the least latency, so we will flash that model on the embedded target. Once the model is flashed, it is ready for live testing. So we connect using Bluetooth and start testing. It starts recognizing the state of running. It would recognize the state of jumping and a state of being idle. We can see here that within a few minutes, Qeexo AutoML builds very high performing machine learning library for the embedded target. There are limitless other applications you can build with Qeexo AutoML. Here we show a few more. For more information, visit our website at qeexo.com. Thank you.
Thank you. Dr. Rajen is joining us tonight from Pittsburgh, so it's fairly late for him. Let's take this opportunity to ask him some questions. So our first question here, what are the other algorithms and classifiers that Qeexo 2 provides in addition to CNN type network?
So in addition, so in addition to CNN, Qeexo has gradient boosting machine, XGBoost, decision trees, random forest, RBF SVM, linear SVM, polynomial SVM, recurrent neural network, convolutional neural networks, and artificial neural networks. Um, 11 different kinds of models.
Great. Our next question here, what about data collection? How much data do you need to collect in order to build a good production quality, reliable model?
So it really depends on the application. As you have seen here, this is a commercial grade activity recognition application. We just needed 50 seconds worth of data for each of the activities, right? Of course, as you add more data, you can gain more performance, maybe. But Kix already also has tools built in to understand that how much data you need. So whether you are collecting less data or whether you are collecting more data or just the right amount of data. So you can actually generate the learning curves, so learning curves will tell you that if you are adding more data, the performance will improve, or you are reaching a plateau so that you cannot see more improvement in the performance. So all the tools are built in to give you an understanding that how much more data you can add and whether adding more data will give you the performance boost. But generally, for most for lots of applications and lots of use cases we have shown here, small amount of data is sufficient because we extract a lot of statistical and signal processing based information from the sensor signals. So we are already extracting rich content from the sensor signals to build high performing machine learning models.
That's really impressive. So what are the default hardware devices that Qeexo 2 supports today?
It supports Arduino Nano 33 BLE Sense. It supports ST microelectronics, ST sensor tile box kit. It supports the ST Win kit, which has a very high grade 26 kilohertz industrial grade accelerometer. It supports the Renesas hardware, so Renesas boards are supported, and some other boards are already in the process of integration. And we also support M0. So the demonstration currently, which we have seen, that is for M4F. But we also have a pipeline in which we can support M0. That is a very, very tiny embedded target. And that is also having the ARM Cortex M0 Plus architecture. And that is available in Arduino Nano 33 BLE IoT device. So that is also supported.
Yeah, so looks like ARM Cortex-M family will be able to support.
Yes, ARM Cortex M family, M0 through M4, everything is supported. So any hardware which can be brought in which has this particular architecture.
Thank you. Next question, how do you handle model drift? How often do you need to retrain computer vision models?
So the platform which I have shown currently, that is an sensor data IoT platform. That is not a computer vision platform. For a computer vision platform, there is a different platform within Qeexo that's called uh, Qeexo AutoML Vision. And please get in touch with with our representatives Tina or Gilbert through our website, and they would basically let you know if you want to try Qeexo AutoML Vision.
Okay, our next question here, what do you do when there is not enough data? For example, the anomaly state, which happens very rarely.
Right, very good question. So Qeexo anomaly detectors actually does not require anomaly data. Qeexo anomaly detectors are trained on the normal data. So you take a normal data which is available in abundant quantity and train a machine learning model, which we call one class machine learning models. So you train a one class machine learning models, and then anything which is not normal will be flagged as an anomaly. So we already recognize the problem that it is difficult to collect the anomaly data, because in order to create an anomaly you might need to create like an artificial breakdown in the systems, which is not possible, right? So you just collect the normal data, and then anything outside the normal data will be treated and flagged as an anomaly. And Qeexo AutoML supports 4 different kinds of anomaly detection algorithms.
Yeah, so you mentioned the different algorithms early. Can you compare all these different algorithms? So how does a user decide whether it's random forest or CNN that is best for the specific problem they're trying to resolve?
Right. So you might have seen in the demonstration that I'm actually building 3 algorithms. And then once I built the 3 algorithms, I'm saying that since GBM is having the highest performance and least latency, I am choosing the GBM algorithm. You can actually build all the 11 algorithms for your given problem. So it will give you the matrix for all the 11 algorithms. So it will give you the learning curve, confusion matrix, library size, latency, performance, F1 score, ROC curve, MCC matrix. It will give all these results in a nice organized way. So you can compare each algorithm against your biases, and then you can choose what library you want to finally flash on the target, and then you can then mass product that particular algorithm.
Thank you. Yeah, if you don't have any further questions for Dr. Rajen, I think we can conclude our second video poster here. Okay. I think one more question. Is the sensor data restricted to time series data? What sensor
uh,
type support?
Sensor data are generally time series data, so they are like all the sensors are generally always on sensors, so they are time series data. But if the sensor data are not time series data and they are event based data, then Qeexo also has a proprietary algorithm to do the event detection first and then bring those events into the machine learning pipeline. So I would say not only time series data, but also the event based data can be done.
Thank you. So thank you, Rajen, for joining us today. We would love to thank our sponsor again to make this event possible and free of charge. So ARM, who provides the software and hardware solutions for tinyML development, we rolled out M55 and U55 micro NPU early this year. And a couple of weeks ago, we rolled out the second generation of micro NPU U65. So if you want to learn more, you should be able to find information in our VIP package. Edge Cortex provides dynamic neural accelerator architecture and co-exploration engine that brings cloud-level performance to the edge. SynSense builds ultra-low power sensing and inference hardware for embedded, mobile, and edge devices. And thank you, our partner organization, Shan, as our conference partner, and our media partners listed on this page. You will find them on our tinyml.org website. So again, thank you for joining us today. This concludes our last day of tinyML Asia 2020. We hope you learned something new in this week, and we hope to see you next year. So please visit tinyml.org for more information. The slide deck and the videos will be posted shortly.